This is Geometry, Unit 6 test review. We're looking over the different formulas. We know that slope is rise over run, so it's change in y over the change in x. The midpoint formula is a location, so we know it's a point. So we have our x values divided by 2 and our y values divided by 2. It's the average of the x's, average of the y's. And our distance formula, which can be represented with Pythagorean theorem, can also be represented with the difference of the x's squared plus the difference of the y squared. Take the square root. If two lines are blank, then their slopes are perpendicular, or their slopes are opposite reciprocals. That would be perpendicular slopes. They're going to cross and form right angles. If two slopes are equal, then their lines are parallel. Tell whether the lines through the given points are parallel, perpendicular, or neither. So we have two lines here. So I'm going to just look at the slopes. So 8 minus a negative 1 and negative 3 minus a negative 6. That is 8 plus 1, that's negative 3 plus 6, that's 9 over 3. This is line 1, we have a slope of 3. This is line 2, we're going to take y minus y and x minus x. That gives us negative 18 over negative 6. That gives us 3. So we have parallel lines because the slopes are the same. Line number 3, negative 4 minus nothing, and 7 minus a negative 1. That gives us negative 4 over 8, which is negative 1/2. Line number 4 is y minus y and x minus x. That's negative 14 over negative 7. That is a positive 2. These are opposite reciprocals. So the slopes are perpendicular. Write an equation of a line that goes through this equation. So line 1 has a slope that is 3. Now I'm going to use y equals mx plus b, and I'm going to plug in one of my points. It doesn't matter which one. 8 equals, that's my y value, my slope is 3, my x value is negative 3, plus the y-intercept where it's going to cross the y-axis. 3 and negative 3 make negative 9, so I add that across, so my b is going to be 17. So y equals a slope of 3, then we say x positive 17. Write an equation that goes through this point and is perpendicular to a given line. Let's make a bit of a sketch of this. We have a line that crosses at negative 5, has a negative 2 slope, and it should be perpendicular going through this point at 4, 5. Needs to be perpendicular. So I'm looking for a positive slope. I'm looking for a y-intercept that might be somewhere in the center of our graph. So we know our slope 1 is negative 2, so our perpendicular slope, what we want, is going to be the reciprocal of that, opposite reciprocal. So I'm going to use y equals mx plus b. Here's my x and my y. My perpendicular slope, my x, but I don't know where it's crossing. That's what I'm solving for. 5 equals 2 plus b. When I subtract the 2 across, my b is 3. My sketch wasn't very accurate, but it did get it within an area, so a smaller number makes sense. So y equals, my slope is a half, that's perpendicular. Don't forget your x, and your y-intercept is positive 3. Place the figure in a coordinate plane that is in a convenient way for a rectangle with the width of A. Doesn't matter where you put it in here. So A is going to be A comma 0. It has to be comma 0. This one's going to be 0 comma 0. My length, the other direction, doesn't really matter where you land, would be 0 comma B. And they're going to meet exactly perpendicular, straight up and straight over. And that's going to be over a distance of A and up a distance of B. It's got to be even with that B, and it's got to be over even with this A. Those would be my coordinates. So here we're going to fill in the missing coordinates. I know that Z is on the x-axis, so we have to have a 0 there. This is a mid-segment, and I know a mid-segment goes midpoint to midpoint. So I need the average of the x's and the average of the y's. So if I'm moving over here, and this is the midpoint, the distance over, this is halfway. Well, if that's 2b, this has to be 1b. For my y values, if I'm going up and I get to c, but I'm on my way to get to double that amount, that would be 2c. That would be the midpoint. Halfway over and halfway up. So I know what my coordinates are. Now I have to calculate here. Well, you can use the midpoint formula. 2b plus 2a divided by 2, and 2c plus nothing divided by 2. Those are my x's. Those are my y's. My midpoint, which is the average of them. This is b plus a, or you can call it a plus b. Divided by 2 is going to cross them out, so it's just a plus b. And here it's 2c over 2. I just get c, which has to be at the same height as this c, because it's going to be parallel with 0. A plus b comma c. We have our values of 0, 0, that's our m, negative 3, 0, negative 8, 8, and 0, 3. 0 right and left, 3 up. So this is M, this is N, this is O, this is P. So I'm supposed to find the distance. I need to determine what this looks like. I have a pretty good idea. We can just look at it and have an idea. It looks like a kite. But let's get our data to support that. MN, this is a horizontal line, so it's 3. It's horizontal, so that's my work. My slope is 0 because it's flat. NO. Well, I can do the distance formula if I want, from N to O. So my x value minus my x value, and my y value minus my y value. Now you could just type that into your calculator. That's the square root of -3 minus -8. I used parentheses appropriately and squared it, plus 0 minus 8 and squared it. And I'm getting 9.43. Well, that's a decimal. Can I do better than the decimal? Well, this would have been the square root of -3 plus 8, which would have been 5. And this would have been -8 squared. So this is 25 plus 64. So that is the square root of 89. Let's see if this is the square root of 89. It's exactly the square root. So that's good. OP. Now a different way to do this is you can use Pythagorean theorem. We're going to look at how much we're coming up and how much we're going over, and this is going to be our hypotenuse. So 1, 2, 3, 4, 5. So we can use 5 squared plus 1, 2, 3, 4, 5, 6, 7, 8, which is 8 squared. It doesn't matter, it's negative, it's just going to be squared, so it's a positive value. And this is our total of OP squared. That's 25 plus 64. Those numbers look familiar. And I take the square root, and I get that square root of 89, which was my 9.43. PM is vertical, so that's a distance of 3. So that's my work saying that it's a vertical line. This slope is rise up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2. Let's be sure I do that again. Over 1, 2, 3, 4, 5. Rise up 8 and over 5. So that would be a negative slope because it's falling to the right. You could call it down 8, positive 5, or positive 8, negative 5. I just put my negative right in front. So our other slope, P, let's see, that was, I'm sorry, that was ON. Got to put it in the right spot or it's worthless. Sorry about that. Hopefully you're not just copying me. That's no good. You need to check your work. OP is, we've already done this, up 1, 2, 3, 4, 5, positive 5, over 1, 2, 3, 4, 5, 6, 7, 8. So they're reciprocals, but they're not opposites. So it's not 90 degrees. And then this one would be undefined because it's straight up and down. So we have two sets of congruent sides, two sets of consecutive sides congruent. It's a kite. We have no parallel sides. So again, that supports it's a kite. Okay. Owen is taking his first geometry exam. He needs to determine the figure that has the most area. So you could use a trapezoid formula. The area is half base 1, 1, 2, 3, 4, base 2, 1, 2, 3, 4, 5, 6, 7. So that's 4 plus 7, and it has a height, because it's perpendicular here, of 5. So this is half of 11 times 5, which is 55. Half of 55 is 27.5. Those are square units. That's one way to do it. Another way you could do it was to break it into a rectangle. That's what I'd expect you to do. 1, 2, 3, 4, down 5 gives us 20. 1, 2, 3, this little bit is 3, up 5, so that's half of 15, which is 7.5. So we had 4 times 5 plus half of 3 times 5. So that's 20 plus 7.5. That's 27.5 units squared. Two different ways to do it. This one, we would be stuck a little bit more to using a rectangle. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 times 5. This is not a trapezoid, so I can't use a trapezoid formula. And I'm going to call this my base. 1, 2, 3, 4, 5. Well, I'm going to take half of that, so half of 5 times, and my height, this has to be perpendicular, so 1, 2, 3. So that's 20 plus half of 15. Wait a minute, that's 27.5. They're the same. They have the same area. Different shapes, same area. To get a perfect score, Owen needs to determine the perimeter of the figure in number 1. Well, we know it's 7 all the way across. We know it's 5 on the way up. We know it's 4 on the way over. What we need to determine is this side. This is 3. This is 5. So 3 squared plus 5 squared is going to equal our hypotenuse squared. And I call that x. So that's 9 squared, plus, not 9 squared, it's just 9, plus 25. That's 34, x squared. So the square root of 34 is our x. So we're going to add the square root of 34 onto this. So our exact answer is 16 plus the square root of 34. We can use our calculator. 16 plus the square root of 34. And we get 2183. Those are just units. They're not square units. That's the distance around the shape. Last two questions. Madeline has a patio, has a new patio, and is scheduled to be poured this weekend. Each unit is a square foot, 1 foot by 1 foot. We're going to plot the points. We have 2, 3, that's a corner, 8, 3, 11, 7, and 5, 7. Okay, classify the figure. Show your calculations. 1, 2, 3, 4, 5, 6. That length is 6. 1, 2, 3, 4, 5, 6. That length is 6. This length is going to be 3 squared plus 1, 2, 3, 4. 4 squared. That's going to be our x squared. So that's 9 and 16. That's 25. So we take the square root of 25. And we get x is 5. And this has the same dimension, so it is 5. So we have and we look at our slopes. We have slopes of 0. Let's see, let's label our points. We have A, we have B, C, and D. So AD up 4/3. BC up 4/3. Makes them parallel. DC equals 0. AB is flat, so it's equal to 0. So it's parallel. They're not opposite reciprocals, so this is just a parallelogram. Two sets of parallel sides. Yes, we have some congruent sides, but that just still supports our parallelogram. Okay, so what's our area going to be? Well, it's kind of a cool formula you can still do. You can do 6 times the height, which is 1, 2, 3, 4. So we have 24 units squared. You can still do base times height. If you don't quite believe that, you can break this into triangles. Most of you would probably do that. 1, 2, 3. 1, 2, 3, 4. So that's half of 12, which is 6. Here's the same dimensions again, so we have 6 again. And here we have 1, 2, 3 times 1, 2, 3, 4. So that's 12. That's a total of 24. So to answer our question, we are $12 for all 24 square feet. We get 288. 2 different ways to calculate that. Good luck.